All right, so again, parts of a circle. So obviously you have the center of the circle, which is the point in the middle, right? So let's call that P. To name a circle, right? So this would be circle P, so circle P, okay? So it has point P in the middle. Right, we also have a radius of a circle, which goes from the center point to the edge of a circle. So the green line is the radius. Right, you can draw it at any point in the circle. It's always going to be the same length. Right, we also have a chord, right, which is a segment that has its two endpoints on the circle. Right, so that's a chord. Right, the longest possible chord of a circle is the diameter, and that's just a chord that goes through the center of the circle. All right, and then remember these outer parts here. So like from here, this curved piece is an arc. Right, and remember arc, so if this is A and B, we'll go back over this in a minute, but it's arc AB with like the little arc thing over it. In section 8.2, we talked about tangents. So, who remembers what a tangent line is? All right, touches the circle how?
It's just like at one point.
At one point, right. So, only at one point, that's your tangent line.
So are we going to have to like match definitions, or are we just going to have to like draw a tangent?
A little bit of both, probably. I haven't made the test yet, honestly.
You should just make it a
No.
circle.
No.
Yeah.
Right, so this point here where it touches the circle is called the point of tangency. Right, and remember that if you draw a radius to the point of tangency, that is going to be perpendicular to the tangent line.
What did you say that line was? No.
It is, all right, so if you draw a radius to the point of tangency, it's going to be perpendicular to the tangent line.
What if you draw a diameter, like a thing, a whole line?
I mean, that's fine, but
What would that do?
it would still be perpendicular.
Will you repeat that one more time?
Yes, so if you draw a radius to the point, draw a radius to the point of tangency, it is perpendicular to the tangent line. So it forms a right angle here.
Oh, I see this.
Okay, can I move to the next slide? Okay. One of you move.
Okay, we'll stop.
I don't care. No, one of you move.
She's never allowed to touch them.
All right, so a common tangent is a line that's tangent to two circles. So remember, we can have common internal and external tangents. Right, so remember the internal ones are tangent, like inside. These are very bad tangent lines, but just pretend that they are. Right, so they go in between. And then external tangents are going to go on the outside of your circles. So they would be, more like that.
Wait, which one's internal?
External is on the outside. Internal is on the inside.
thought about that.
I will make one of you two move next.
Quit getting me in trouble.
It's okay. Right, so again, internally tangent circles are inside one another on the same side of the tangent line. Externally tangent circles are on opposite sides of the line, but tangent at the same point. There's 5 of them. All right, so 8.3 is arc measure and length. So make sure that you know the definitions for semicircle, minor arc, and major arc.
And those are?
All right. So semicircle has an arc measure that is exactly 180 degrees. Minor arc is less than 180. Major arc is greater than 180.
Alright, that's a lot easier than I thought it was going to be.
All right, so then when you have a circle, so if you have an angle that is formed at the radius, so that is called a central angle. And so the central angle measure is equal to the measure of that arc. So, for example, if this is we're just going to say that's a 90-degree angle. That means that the measure of this arc is 90 degrees. So that's the intercepted arc. All right, so if your angle is in the center of the circle, so if it's formed here at the radius, like from the center, then that means the central angle measure is equal to the arc measure if it's in the middle. And the next section is when we get to the ones where we cut them in half. Yes. Okay, so remember the other thing we did was we found the arc length. So that was when we did the central angle measure times the circumference, which is 2 times pi times the radius, and then divided that by 360. So remember, this is the Greek letter theta, and that's our central angle measure.
Looks like the cursive of R. You should answer that.
Hello. Okay. Yep, I will be there. Thank you. Okay, thanks. Bye. Oh, forgot I had a doctor's appointment tomorrow. Don't worry, I'll be here in time for class, guys. Don't get your hopes up.
Oh, okay, with my hopes. Tell him you can come now.
My appointment's at 7:45 tomorrow morning. I think you'll be fine.
At night?
In the morning. I literally just said the words "in the morning."
At night?
No, that's my bedtime.
Well, 7:30 in the morning seems really early too, though.
Well, I mean, yeah, but I'm.
Not for a doctor's appointment. You have to be here before 8 o'clock, Caitlin. I'll wake up at 5 o'clock.
Okay, so that's really it for 8.3.
Wait. Will you be here for this class?
Yes.
What about my physical stuff?
Yeah, I'll be here. Like, it's just a quick, like, follow-up appointment for some medicine I'm on. That's it. Cord.
You're laughing.
Okay, so 8.4 is inscribed angles. All right, so remember, an inscribed angle is
I wrote angels.
what?
Oh, that.
Right, so it's an angle whose vertex is on the circle.
Solomon, guess what?
Angle is an angle whose vertex is on the circle. Yes. I mean, not all the way, but enough to hopefully. Yeah. Right, so that is an example of an inscribed angle. So remember that the measure of an inscribed angle is half the measure of its intercepted arc. So if this is our intercepted arc, and let's say it's 60 degrees, what would our angle measure be? 30. The angle measure is half the arc measure. So if you were given the angle measure, what would you do to find the arc measure? Double it. Good job. All right. This is when we're dealing with intersecting lines and circles. So if you have lines that intersect inside the circle, it means that this angle measure is half of the two arcs added together. Or well, really, so you do like add those two and then divide it by 2. So if this is, so we'll say this is arc 1, this is arc 2.
Shut up.
All right, so again, that's if the lines intersect inside the circle.
The angle measured half of
The sum of the two arcs. So like arc 1 would be this, and arc 2 would be this.
Would those angles, would those be the same as inscribed?
Yes. No.
Or whatever it's called?
No, they're just angles inside the circle. There's not any particular
Is there a
name.
way to find them if you had to find them?
Find the angles? Yeah, that's what.
Is that the inscribed angles?
No, that's this. You add the two.
That's to find the angles?
Yes.
Is use the arc?
Yes.
Oh, okay.
Yeah. So let's say, for example, this arc is 50 and this one is 70. So we would do 50 plus 70 divided by 2. So that would make this angle 60 degrees. Okay. All right, and then if the angles intersect outside of the circle, can I go to the next slide?
No.
Shh.
Is that like 170 divided by
120.
Probably.
All right, my goodness. They intersect outside of the circle. Oh, that's really bad. There we go. All right, so our intercepted arc. So like we have this little arc and we have the big arc. So you do the big arc minus the little arc and then divide it by 2 to find this angle measure. So big arc minus little arc. So big, little, divide by 2. So let's say this is 80 and this little one is, I don't know, 20. So you would do 80 minus 20 divided by 2. So that would make that angle measure 30 degrees. Right, so if the lines intersect outside, you subtract, inside you add.
I know before if the angles are touching each other and at the center.
They don't necessarily have to be at the center. Yeah, so like the vertical angles are going to be the same.
Okay.
Yeah. Okay, any questions? All right, so tomorrow you can use anything. Listen, I'm still talking. You can use anything in your notebook not your textbook. So make sure you have all your notes and homework together for this section. It will come in handy.
Is that what?
Yeah.
Is that it?
Yes.
Okay.
You nerd.
Yes.
Do we have a license? Do we have an license?
No, you guys go to